would like to introduce Peter Palensky, who talked about smart grids. Hello.
Hello.
Well, at first, please tell us about maybe complexity of the models. So building a model of a small grid is relatively simple, I think. However, what about building much bigger models, for instance, for a whole city, voivodeship, or whole country?
Mm-hmm. Well, complexity requires certain ingredients. One of the easiest one is if you have memory within the model. So the moment you have a closed loop control, more of them that are interlinked, you enter complexity, where a small little change could lead to a very surprising result in the end. Yeah? And as we are adding digital controls and little computers everywhere in the grid, they do have memory, they do make decisions, and it's hard to analyze and estimate all the variants of the future scenarios that can grow out of that. So this is one of the reasons why we believe that the smart grid has lots of complexity inside.
Okay, so I would say the more elements we are trying to add, different elements, because adding 10th, 1,000th, and etc., the same element is not a big deal. But when you're adding new kinds of elements, it will, I would even say, add new problems exponentially, not just linearly.
Yeah, the point is that the information technology has different speeds. In the past, the growth within the grid was observable. We had experience over decades. The load was growing 2% per year, and then we installed another power station, and that was it. Now we have disruptive phenomena that, you name it, there is a new toy, a new tool, a new box that you can buy in China, which does something great, which costs nothing, and everybody installs it, but this thing has a bug. Yeah? On a certain day, they all freak out at the same time, but nobody knows. This was not possible in the grid before, but now the more electronic devices we have in there, for instance, the inverters for the rooftop photovoltaic or the charging stations for the cars, they are all electronic, they are all digital, they all run on Android or whatever, and that's why we have this big lever now if something happens. And in the past, all that was not so important because we had these big power stations that levelized everything. So even if some cars or inverters freaked out, nobody cared because it was all balanced out by the big power stations. But the big power stations are dirty and we don't want them anymore. So they're phased out. They're either nuclear or coal, and so that's what's going away, and it's replaced with wind and solar, which is good from an environmental perspective, of course, and we need that to save our planet. But the stability of the grid doesn't like that.
Yeah, well, that's true because wind doesn't blow all the time of the same strength, I would say, right? So from time to time,
in the night is also a seldom phenomenon.
Exactly. So I would say that this is one side, but the other one is that the amount of data that all those data sources, I mean, all those devices, toys, as you said, that they just generate. It's the amount of data that they generate is huge, right?
Yeah. Well, the power companies believe that lots of this or much of this data can be used for their purposes, for load forecasting or other things that would make their business easier. But currently, the IoT is not yet in that range. But the power companies are already overloaded with data, even without the IoT, because there is smart metering, which is not big data. It's a lot of data, but not big. And now they are installing the PMUs, the phasor measurement units, which give high resolution, high fidelity signals from the grid, and they produce streams of data. That's a new level of quantities of data that the power companies are currently fighting with. And they are quite busy in keeping that under control. IoT is the next level that will come soon.
Yeah. Well, a few years ago, I talked with Marco Aiello from the Netherlands, and he told me about the smart grids project, and when they tested or verified the quantities of data that would be produced for the whole country, it was, if I remember well, something like over one or a few petabytes per year. So something that worked fine for even quite a small city or a local area started causing severe troubles when thinking about going to the level of not that big country.
Yeah, well, it's the question if we need all that data. For instance, the smart meters that are installed everywhere around Europe currently, they do have lots of data, but only a little bit leaves the house. So it has internally lots of data. You can look at it, you can use it for your own purpose, but the billing information is little. It's especially when you make it intrinsically safe, so that your load profile doesn't leave your house, but it's calculated into euros on your premises, and only the bill, I mean the euro bill, leaves the house. Then it's not a lot of data. And these seconds and minutes resolution as well, not. Maybe hourly resolution leaves the house if you want, but that's not so much.
Well, that was about optimizing the load of the smart grid. So they needed to control what is being turned on, how much power is consumed, etc., etc. It was the same case as you told today, with changing the hours of operation of some devices. For instance, charging the car at night, but when to start, maybe 1 hour later or 1 hour sooner.
There are different ways on how to govern or how to control a distributed system. One extreme case is you ask everybody, you make up your mind and you tell everybody. That's the cloud dictator. He knows everything, or she knows everything, and then controls everything. But the other extreme is that you just broadcast incentives or rules, like a price. There is an energy price, and you update it every 5 minutes or every hour, and then everybody has to make its own decision. There's a little communication involved. You could do it by a radio broadcast, one-way communication. And in between, there is every shade possible. Hierarchies, self-organizing groups of alike customers that collide to a coalition to do something. So if the bandwidth and if the quality of service and if the data amount is the problem, there are ways out of this. It's not needed that we transport everything from A to B, start the big number cruncher to come up with their optimal solution. Of course, if you have all the data, you can find the optimum, but this will never happen. It will be a local optimum, it will be suboptimal, but it will be good enough. But it's more robust to keep the data where it is and to use it where it is.
Okay, and I would ask what to do, or in what way you can determine how often those end elements should be told or informed in any way that, let's say, the conditions in the smart grid are changing, because they have to know that something is going on. For instance, that the power sources are very close to the limit, so that you cannot, right now, you cannot just start charging the car, because there won't be enough power, right?
Yeah. It depends on what phenomena we are talking about. If it's something market-based, I believe markets will not go beyond or under a minute. We have now markets that talk in days. And we will go to hourly markets and maybe something quicker in the future, where you have an online price or a real-time market where each and everyone could participate. That's already a lot of communication, a lot of things going on. And there's active research on finding out if this is worth doing it, if this is more stable or more fair or more economic than what we have up to now. Everything that leaves the market and goes into controls is much quicker. There are phenomena which are in seconds, and there are phenomena which are in milliseconds, and there are even phenomena which are quicker than that. So if you go into protection and these things, not everybody has to participate in these processes. Only critical infrastructure, they have connection with high availability, high speed communication infrastructure, but not the average IoT doll of your daughter.
Well, of course, but when I was thinking about it, I was thinking about millions of citizens and millions of homes, and inside of every home we have not dozens, but nowadays we are getting close to, I would say, even hundreds of various devices that consume power, and for most of them, of course, information every minute, every 30 seconds is just pointless, right? But maybe once per 15 minutes, once per hour, something like this, maybe this will be necessary.
It depends on what scenario you have in your mind. If we would continue the style of the last 100 years, I would say, make a strong grid, big wires, big power stations, everything will be fine. We are slowly leaving that philosophy for cost reasons. And even the structures, the topologies that we have now and that we take for granted and which were costing gazillions of euros might be away in a not so distant future. And we might see a change in how our power system operates. So this is very speculative, of course, but if you take the greenfield approach in development countries where you are starting from scratch, they might not do these things as we have done it 100 years ago. So they might have self-organizing microgrids, which has some disadvantages. They might not be as efficient as a strong grid. Strong grid is easy, perfectly efficient and easy to maintain. But its scale's not so good, it's more expensive. If you have these smaller grids where everybody has a little bit of generation, a little bit of storage, a little bit of load, which usually works, but not always. Sometimes it just doesn't match, then you ask your neighbor to help you. You have maybe 5 neighbors and that usually works. And you make a mesh. Then you might not need too much transport infrastructure anymore. This does not work in a million cities. There you need a grid. But we will see new topologies and we will see new ways of providing energy services, whatever that might be. Connectivity with a certain quality. Maybe this quality will be not as good as we know it now. Always on, might not be the case in the future. But maybe this is not important because every lamp, every device will have a battery anyway.
Yeah, and another thing that I was thinking about is that not every device is equally important, and of course not every device has equal requirements for energy, right? So we have some devices that will be more, or rather will require more information about the state of the grid, no matter if it's going to be a strong grid or a local grid. And we'll have devices that will be less dependent on that information, right? So those Chinese toys that will consume, let's say, 2 or 3 watts of energy will be not that important as, for instance, washing machines or chargers for cars.
Correct. That's the quality of the power quality. Yeah? It's not only the voltage and the harmonics and everything else that we see on the power quality, but also the availability and maybe the price. And we are used to have just one type of power quality. It's one socket where we connect everything. In some offices you already see a white, a red and the green socket. The green socket is always on, the red maybe not, and the white is average or so. Yeah? So these are already different qualities that you provide, and in the future it might be even more. Things that it's like with currencies. Everybody thinks there is one currency. Yeah? We are currently experiencing other currencies popping up, and maybe in the future we will have thousands of currencies. And the same with the power quality. Maybe it will be different types, different sources. You take it from the environment, from some grid, from your neighbor, from the car that comes home. And in the end, you will have your own budgeting of energy.
Well, my thoughts were not that far going. I was thinking rather about looking for some more sophisticated way of informing all those devices. I mean, not equally to all of them, but rather choosing which of them are more important and which of them require more frequent information, and the rest of them, which are not that important, will just wait longer, right? So
this is already happening. So in other markets where you are refunded for these types of flexibility, like in California, there you have it. An aggregator offers you a smart box for your air conditioning system, and this listens to a radio signal. And you can tell him, okay, I go down to that level, and this means I get $20 per year as a refund. This can be more sophisticated, that you create categories and rules when you can be switched off or not. The pump of the swimming pool or the washing machine and other things can be scheduled. And depending on how much is that worth, it's done or not. In Europe currently, the balancing market and all the other markets that would benefit from such flexibility that the intelligent devices in the end would offer is not strong enough to justify it. It's only done in experiments and in little tryouts. But the technology is there, and there is also market mechanisms ready that could host it. You can make transactions on that, and depending on what quality you have in your grid, as we've seen in the California energy crisis, they had troubles, and they tried to reduce the load, and by demand-side management, demand response, and intelligent loads, they could basically solve the situation partly. And when we have the same situation in Europe, we might do the same, and then the intelligent devices will get very, very popular.
Okay, so we'll see what will happen in a few years, I believe. Okay, so thank you for our conversation.